Hello everyone, welcome to Memo Neet. How are you all doing? See, I hope everyone is doing good. So, students, I'm Aprajita, your chemistry SME, and I welcome you all to another session for chemical kinetics. So, if you people have not watched the first lecture yet, so it is live on YouTube. Go and watch the chemical kinetics part 1. This is your part 2 for chemical kinetics, where I'll be taking the remaining topics of this chapter. Okay. But before that, I want to ask you about the questions I gave you. I cannot see any comment on the video yet. I gave you 2 questions to solve during the video. Okay, it's not in the starting, it's not at the end, it's during the video. So if you are going to watch the complete lecture, then you will find out that which questions I have given you and I'll be wanting the answers for that. So not even a single student has actually given the answer. This is highly disappointing actually, because we are putting in so much efforts for you people. We are giving you the complete lectures, everything in detail, and in return we just want some response from you. So I told you to give the answers for those 2 questions, and those were like damn easy, very easy questions. One part I have solved, other part I told you people to solve, but still I have not got any comment on that. So please go and comment the answers there. I'll be wanting to see if we see the comments now, it becomes easy for us to understand that you people are understanding the lectures or you are watching the lectures. Okay, so please go and watch that and it will be definitely helpful for you. See, these lectures are made from NCRT. Okay, these are NCRT based lectures, because in NEET we can find out the questions directly from or indirectly from NCRT, but we have to follow NCRT religiously. It's like a Bible for us. Okay, so, and that will be helpful for your exam preparation, board exam preparation also, or like for your 11th and 12th class exams as well. So it's giving you double benefits because we are discussing all the lectures in detail. So please go and comment the answers, whatever questions we give you to solve. And moreover, I asked you if there is any problem in any topic, do let me know so that I can make a separate video for that, right? So please do it, and I want the answers on the first video where I have given you 2 questions, alright? So today we will be starting with the second part. So in the last part I discussed firstly what is chemical kinetics, means what do we study in chemical kinetics. We have discussed that. So this is just a recap of what we did in the last class. Okay, then we discussed about the rate of reaction, and then how the rate of reaction depends on the concentration. Rate constant के बारे में पढ़ा. We studied about rate constant, its units, then how rate of reaction depends on the concentration of reactants as well as on the concentration of products. Okay, then we saw about the integrated rate equation for the zero order and first order reactions. So derivations I have discussed with you, the integrated rate law. We studied the rate law equation also. Okay, so rate law equation, then we studied integrated rate law. We studied about the order and molecularity of the reactions. So all these major topics, these are very important from NEET point of view. We have discussed in the last class. If you have not watched it yet, please go and watch that. And yes, now for today what we are going to do, we will be seeing what are pseudo first order reactions. Okay, we have studied about the order of reaction now. So what is pseudo first order reaction? We will see that. Then we will see the temperature dependence. This is very important, temperature dependence on rate of reaction. Then we will, in this topic only, we'll be learning about the activation energy. Okay, the Arrhenius equation, and then we will be talking about catalysts and the collision theory. So these are also important topics that we will be studying today in today's lecture. Okay, so be actually serious about these lectures that we are giving you, because these are from NEET point of view where we are discussing all the topics, and I'll be also telling you in between key what are which one is the most important topic, where you will be getting the questions from, what kind of questions you will be getting. Okay, so these are the important concepts that we'll be learning today. Let us first start with pseudo first order reactions. So students, if I talk about a normal first order reaction, you know, for a first order reaction, the rate actually depends on the concentration of the reactant. Okay, the power will be 1. So that will be the first order reaction. But if I talk about pseudo first order, pseudo means it is not actually a first order reaction, but it appears like or it behaves like a first order reaction. Okay, so why that happens? Because the order of the reactions is altered by the conditions. Now let's say if I am having a particular kind of reaction where one reactant is in excess. Okay, the comparable nahi hai, one reactant is in excess. For example, let's take hydrolysis of ester. Okay, we are taking hydrolysis of ester. So in this reaction we have taken hydrolysis of ethyl acetate with 10 moles of water. Now you see 0.01 mole of ethyl acetate and we are hydrolyzing it with 10 moles of water. So just see ki here water is in excess. Okay. So let's say if at T equals to 0, this was the number of moles and the number of moles of the products were 0. And at time T, all the ester has been hydrolyzed, like 0.1 mole of alcohol and acid we have got, but still we are left with 9.9 mole of water. Means the concentration of water is not changing with the course of the reaction because it is present in excess. Itni zyada quantity mein it is present that the concentration will not get altered during the reaction. So in the rate equation, so you know rate equation will be like K dash, okay, CH3COO C2H5. This is the concentration of the ester and concentration of other reactant also. But you know ki if the concentration of water is not changing with the time, okay, it is not changing with time, so you can take it to be constant. And if we multiply a constant with some constant, we will get another constant. So it means K dash into concentration of water को हम लिख सकते हैं K, and it will be only dependent on the concentration of the ester. Okay, so K is K dash into concentration of water. So see, this reaction was not actually first order reaction, but it appeared to be, right? बट देखो यहाँ पर इट वॉज अपियरिंग टू बी सेकेंड ऑर्डर अपियर हो रहा था, बट इफ वाटर इज प्रेजेंट इन एक्सेस, अगर हमने रिएक्शन कंडीशन चेंज कर दी, इफ वाटर वॉज नॉट प्रेजेंट इन एक्सेस, तब ये सेकेंड ऑर्डर ही बिहेव करेगा, राइट? बट if we have changed the reaction conditions, means if we have increased the amount of water, we have taken it in excess, so wahan par the concentration of water will become constant and the reaction will behave as a first order reaction. Okay, so in this case we will be calling it as a pseudo first order reaction. So yahan pe you just need to remember these 2 examples, all right? Like the inversion of cane sugar is also an example of pseudo first order reaction, because here again the rate of the reaction will depend on the concentration of the sucrose only. Okay, so that was the meaning of pseudo first order reaction. I hope it is clear. Moving ahead, students. Now, very important topic. A lot of questions are asked in Neet from this topic. Arrhenius equation, temperature dependence of rate of reaction. All right. So, please try to understand it and focus here on what we are going to discuss. So you know rate of reaction ko we can change with the temperature. Earlier we studied how the rate of reaction could be changed with time, with concentration of the reactants. Now we will see ki how the rate of reaction depends on the temperature. So students, you know ki most of the reactions are accelerated by increase in temperature. We will increase the temperature and the rate of reaction will increase. Now why that happens, that's what we are going to study today. All right. So in this case, if we are taking the decomposition of nitrogen pentoxide N2O5, time taken for half of the original amount to decompose is 12 minutes at 50 degrees Celsius. Now see, if I am studying decomposition of nitrogen pentoxide, so at 0 degrees Celsius, half मटेरियल को डिकम्पोज होने के लिए 10 days लगेंगे. Okay, But if I increase the temperature to 25 degrees Celsius, half decomposition होने के लिए it will just take 5 hours. Just see, from 10 days it is just reduced to 5 hours. And if I increase it to 50 degrees Celsius, so the reaction will just happen in 12 minutes. Can you see, just by increasing the temperature, how fast the reaction has become? Earlier it was happening in 10 days at 0 degrees Celsius. But now at 50 degrees Celsius, it will be happening in just 12 minutes. Okay. In the same way, mixture of potassium permanganate and oxalic acid if we are having, so potassium permanganate gets decolorized faster at higher temperature. Okay, so this was a general behavior was seen in the reactions ki generally it will be increasing with increasing temperature. So it was found out experimentally, of course, that for a chemical reaction with rise in temperature by 10 degree, ki if you are increasing the temperature by 10 degrees Celsius, the rate constant will get doubled. Okay, rate constant means K. Okay, rate constant will get nearly doubled, and this temperature dependence can be explained by Arrhenius equation. So Arrhenius equation is rate constant K is A e raised to the power minus EA upon RT. Now what is this A? A is Arrhenius factor or frequency factor, और इसको हम pre exponential factor भी कहते हैं, and it is specific for any particular kind of reaction. R is the gas constant, T is temperature, and EA is the activation energy. Now the question arises ki what is activation energy? Yes. So see, when you have to change a reactant into the product, how will the reactant change into product? So those reactant molecules will collide with each other, right? And then the product will be formed. Collision theory mein we will study it again. Okay. So whatever external, and they'll be having some energy, okay, but to get converted into product, sometimes let's say that a reaction is not feasible at that particular temperature. So if we increase the temperature, means if I provide some energy, so that minimum amount of energy, that external energy that we are providing, which is required to change a reactant into product, is called the activation energy. Means we are activating the reactants in that case. Okay, let's say if, this graph is very important. Okay, try to understand it. Let's say if I'm having a reaction between hydrogen and iodine to form hydrogen iodide. Okay, so what happens is this reaction proceeds to the formation of an intermediate. Ki when a molecule of hydrogen and iodine, so can you see this intermediate here? So this reaction proceeds to the formation of this intermediate. So hydrogen and iodine molecules will collide with each other. They will form that unstable intermediate, and like it exists for a short time only because it's an unstable intermediate, right? So it will get converted to hydrogen iodide molecules. Okay. Now, so let's say this is the energy and this is reaction coordinate, means as reaction proceed. So this was the energy of the reactants earlier, this at A point. Okay, like here this was the energy of the reactant, and this is the energy of this activated complex that we have formed, this intermediate. So itni energy, this much energy we need to supply. Okay, we need to supply this much energy to the reactants, so then only they will collide and they will form that activated complex. Okay, so this energy is known as activation energy. So the energy required to form this intermediate will be called the activation energy. Okay, fine. And when this substance will decompose to form product, so you can see the energy of the product is less than that of the reactant. Of course it's stable, and this will be delta H for the reaction. Okay, this much energy is liberated or absorbed during the reaction. So यहाँ पर of course energy would be liberated because the product have lesser energy. Okay, So this is what activation energy means. I hope you have understood, like whatever extra energy you have to provide to make the reaction proceed. All right. So that is known as activation energy. So now students, let us understand this concept in more detail, like how the temperature affects here. So you know that we are having different kinds of molecules in the reactants, and those reactant molecules, all of them will not be having same kinetic energy. Of course, they'll be having different kinetic energies, all right. So it is difficult to predict the behavior of any one molecule with precision. So statistics ke concepts were used to predict the behavior of large number of molecules. So how can we describe the kinetic energy of that reactant molecules? So we can plot the fraction of molecules with a given kinetic energy versus kinetic energy. This is the kinetic energy, and how many fraction of molecules are possessing that kinetic energy, okay, that we plot here. Okay, so fraction of molecules means how we'll calculate. Ne is the number of molecules with that particular energy, okay, and Nt is the total number of molecules. So if we divide it, we will get the fraction of the molecules having that particular energy E. Okay, now you see this graph. This is first increasing and then decreasing. So means here at the peak, what does this peak indicates? It indicates most probable kinetic energy. Most probable kinetic energy is the kinetic energy possessed by maximum fraction of molecules. Maximum number of molecules, maximum fraction of that total number of molecules is possessing that particular kinetic energy. So that will be your most probable kinetic energy. Understood? If you are having any issues, you can let me know in the comment section also, all right. So you can see that there are decreasing number of molecules with higher or lower energy. So agar lower energy ki baat kare to bhi number of molecules is decreasing, and higher energy ke liye bhi it is decreasing. Okay, now what happens is that when you are increasing the temperature, okay, what happens is when you are increasing the temperature, the maximum of the curves move to the higher energy value and the curve broadens out. Okay, you can see here in this graph that the maximum, this earlier this was the maximum, now the maximum of the curve has moved. All right, like here this was the maximum, and now what has happened, t plus 10 pe this has moved and the curve actually broadens out like this. Okay, now you can see, let's say if this is the activation energy, okay, this is the activation energy, and these much molecules possess that activation energy, so they will be like colliding with each other and proceeding with the product. But at t plus 10, what is happening at t plus 10? The fraction of molecules having that particular energy is increasing. The area under the curve is increasing, right? Can you see that, students? Let me show you again. See, observe here that the area under the curve, earlier it was this. So these much molecules were having that energy, fraction of energy which were reacting. Okay. So now when we have increased the temperature, the curve has broadened out. All right. And the number of molecules possessing that particular energy or number of molecules reacting will increase. Okay, so that's how the temperature dependence is or can be shown by the graph. So this is important. These two graphs are important. Keep that in mind. Okay, what is most probable kinetic energy? I hope you have understood. Now, so what we have seen is that increasing the temperature of substance increases the fraction of molecules which collide with energies greater than activation energy. Okay, and the area showing the fraction of molecule gets doubled. So rate of reaction will be double for every 10-degree rise in the temperature. Okay, now how to get an equation? Now there will be an equation that we will be deriving, okay, for this thing, your एक्टिवेशन एनर्जी, क्योंकि इसके बेस पे न्यूमेरिकल्स आते हैं. सो कीप दैट इन माइंड, यू विल बी गेटिंग न्यूमेरिकल्स बेस्ड ऑन दैट. So focus on this derivation now. Now this Arrhenius equation, if I am talking about this Arrhenius equation, we have K is equal to A e raised to the power minus EA upon R T. Now this E raised to the power minus EA upon RT, it corresponds to the fraction of molecules that are having kinetic energy greater than activation energy. So if they are having kinetic energy greater than activation energy, these number of molecules will be colliding with each other. Okay. If I take natural log on both sides, so natural log K, and यहाँ पर if you take here the natural log ना, so this E will cancel out, so you will be getting minus EA upon RT plus natural log A. Okay. Now compare it with the straight line equation y is equal to mx plus c. So if I draw a graph, so here y I am taking as log K and x is your 1 by t. So the slope will be minus EA upon R and intercept is log A. Okay. So you can see log K and 1 by t ka graph, a straight line graph, okay, with the negative slope. Okay, so this you must know graph. Now what we will be finding out here, that from this Arrhenius equation we can say if we are increasing the temperature, so it will decrease the activation energy, so it will result in increase in rate of the reaction and exponential increase in the rate constant. तभी double हो रहा है, right? It's getting exponentially increased. Now from here, if we have got this equation, slope is minus EA upon R and intercept is natural log A. So we can calculate the value of activation energy or this Arrhenius, this factor A. Okay. Now let's say at temperature T1, the rate constant is K1. So log K1 is minus EA upon RT1 plus log A, and at temperature 2, this is the equation. Okay. So K1 and K2 are rate constants at T1 and T2. Now you can subtract the equations. Okay, so log K2 minus log K1 you will do. So EA upon R T1, क्योंकि negative में था ना, तो T1 term will come first and R T2. So log K2 upon K1, EA upon R will take common. You know all these things how it is to be done, right? So if I change it to natural log na, so it will be 2.303 natural log K2 upon K1. I think this is clear. If you have not done maths, you should know कि if I have natural log A, if I need to convert it to log to the base 10, so it will be 2.303 log to the base 10 A. This you must know. So 2.303 will be multiplied here, EA upon R. 1 by T1 minus 1 by T2. So 2.303 ko we will take it to the right hand side. So EA upon 2.303 R. You can take LCM here, T2 minus T1 upon T1 T2. Okay. So when you take this LCM, this is the relation that you have to remember. This will be the one that will be used for the numericals. So what they will do, they will give you the, like at T1, the rate constant is K1, so and so, and at T2 the rate constant is K2. Or what they will do is, what kind of questions you get, ki when the temperature let's say was 25 degrees Celsius, the rate constant was something, and if the temperature increased to let's say 75 degrees Celsius, the rate constant becomes 4 times. Okay, 4 times हो गया. So यहाँ से you will be just putting 4K upon K, and यहाँ पे you will be putting the values, but make sure the temperature you are taking it in Kelvin. Okay, you know the value of R, so calculate the activation energy. So from here you can do. So such type of questions will come. Ki with increase in temperature, the rate constant becomes 4 times its initial value. Calculate the activation energy for the reaction. So for that you must remember this formula. Okay. So please remember this, okay? Don't forget the formulas. Now you will be thinking, ma'am, there are so many formulas, what we will be doing, like how we'll be remembering. So what I would suggest you is make a separate flow chart, alright? Separate page pe write all the formulas of this particular chapter. Or you can make a small notebook. I used to do it like this, ki I used to make a small notebook that write the chapter name. For physical chemistry only you will be having formulas, na, mainly. So Like for solutions chapter you have, for mole concept you have formulas, for chemical thermodynamics you have. We are mainly covering abhi physical chemistry portion, no? So write the chapter name, write all the formulas at one place. Okay. So when you will write also, you will remember, you will memorize as well. So that's why I'm telling you to write it down. So for chemical kinetics also, you have rate constant ke formulas, T half values, everything. This all. So units, even units also are important, right? So make a separate notebook for that. If you cannot do it, so in MEMONEET app, we have this Brahmastra Revision Patrika, okay, BRP, Brahmastra Revision Patrika. If you are having that elite plan, you will find it out. In BRP for chemistry portion, we have points to ponder, okay. So we have points to ponder. In that points to ponder, for each chapter, you have got this thing that I'm telling you to do. There we have these notes and we have these formulas for you. Okay, उसमें like एक ही जगह पर सारे formulas लिखे होंगे short में. So you can go through it. Like if you want, if you are revising the chapter, you just want to revise the formulas, open that thing in your app, in MEMONEET app, and you will find out all the points to ponder, like everything, all the formulas and the notes at one place. Short, crisp notes. Okay. Detail mein to we are dealing here only, but if you want in short, you can go there. Otherwise, try to make it in your notebook. Okay. Next up, we have effects of catalyst. Very, very, very important. Now, what is catalyst? Catalyst is any substance that increases or decreases also the rate of reaction without itself undergoing any permanent change. So usually we use, see, it's not that every time it will increase only. It can decrease the rate of the reaction also. So the one that increases the rate of the reaction are called positive catalysts. And the one that decreases the rate of the reaction are called negative catalysts. Okay. Now, they will themselves not undergo any change. They are not participating in the reaction, okay? Means after the reaction is complete, you will get the catalyst as it is. Okay, like if we are having this particular reaction, potassium chlorate is decomposing to potassium chloride and oxygen. So manganese dioxide is used as a catalyst to increase the rate. Now, how is the catalyst going to increase the rate? Yes. So this is the like graph of the reaction path, like path of the reaction without catalyst. So this is the activation energy required. Now, higher energy is required, right? Now, what catalyst will do? Catalyst will provide an alternate path. It will provide an alternate path so that it reduces the activation energy for the reaction. Now you see lesser energy. Now this much energy is required. Earlier this much was required. So it has reduced the activation energy so that reaction can proceed in a in a faster way. Okay, so it will increase the rate of the reaction by providing an alternate pathway by reducing the activation energy between the reactants and products. So जैसे activation energy कम हुई, अब हमें कम energy देनी है, so time will be less. So because molecules will be gaining that energy in a lesser time, so you will get a faster reaction. Okay, so this you must know, the graph you must know. Okay. See, this catalyst, it does not alter the Gibbs energy of the reaction. It catalyzes the spontaneous reaction, but it does not catalyze non-spontaneous. ऐसा नहीं होगा कि if reaction is non-spontaneous, it will catalyze. No. Okay. Catalyst also does not changes the equilibrium constant for the reaction, but it will help in attaining the equilibrium faster. कि that reaction proceeds faster, तो equilibrium भी जल्दी attain हो जाएगा. Okay. So it will catalyze the forward and backward reaction to the same extent only, so that equilibrium state remains same, but it is achieved faster. Okay, faster achieve ho. So that is the work of catalyst. Okay. So we use positive or negative catalyst, but if it is reducing the rate of the reaction, we can use the word inhibitor also. Okay. Fine. So temporary bonds बनते हैं. I told you if it is participating in the reaction, temporary bonds will be formed with the reactants, and after that, when product is formed, catalyst will be as it is. Okay. Next is another important concept, which is collision theory. Ki how the reactions takes place. Collision theory of chemical reaction. Let's see. Okay, students, so if I am talking about collision theory, what is collision theory? So according to this theory, we are considering the molecules to be hard spheres. So we are assuming that molecules are actually hard spheres and they are colliding with each other, right? Like you have studied collisions in physics, elastic and elastic collisions. So it is assumed that these molecules are colliding with each other and then they are gaining sufficient energy to overcome the energy barrier and then convert into products. Okay. So this thing, the number of collisions that are happening per second per unit volume of a reaction mixture is called collision frequency, and this collision frequency is denoted by Z. So that you must know that the number of collisions happening per second per unit volume for the reaction mixture will be the collision frequency. Okay. So we have studied about the activation energy also, right? For any bimolecular elementary reaction, so the rate of reaction would be Z. Z means the collision frequency, then EA upon RT. So it will be depending on the activation energy as well. Okay. So ZAB is again your collision frequency that we have just discussed. Number of collisions happening per second per unit volume. And this factor, this second factor, it represents the fraction of molecules, as we have already discussed, fraction of molecules having energies equal to or greater than the activation energy. Okay. So इस equation को we can relate with the Arrhenius equation, which is A e raised to the power minus A upon RT. So we can say this A is related to the collision frequency. Okay. So actually we can calculate the value of rate constants accurately for the reactions which are having atomic species or simple molecules. But if we are having complex molecules, so in that case many deviations are observed. Okay. Now why those deviations are observed? Because the reason can be that all the collisions are not leading to the formation of product. Right? It's not necessary that all the collisions are leading to the formation of product. So what we can say is that the collisions in which molecules collide with sufficient, they must have sufficient kinetic energy na, so that they can cross that energy barrier and then they can get converted to products. So दो चीजें हैं यहाँ पर. Two things you have to keep in mind. This is also important. This was asked in Neet also. कि the collisions must have sufficient kinetic energy first. That is called the threshold energy. And they must have proper orientation also. So collisions तभी effective होंगी. Effective collisions की हम बात कर रहे हैं. That if they are having sufficient kinetic energy, means the threshold energy, and proper orientation, so that bond breaking happens and formation of new bonds happens, and this is called effective collision. So effective collision mein you have to remember two things. Okay, sufficient kinetic energy and proper orientation is also important ना, कि उस orientation में ही collision हो रही है तभी product बनेगा. Otherwise if random collisions are happening, it's not necessary the product will be formed. All right. For example, if we are taking formation of methanol from bromoethane, so this is an organic reaction you can see here. So this is actually they have taken bromomethane and bromoethane nahi hai, this is bromomethane and this is methanol. Okay. Now you can see what is the proper orientation and what is the improper orientation. So what happens is when you will study organic, you will see ki the attack of OH happens. Okay, the attack of OH happens on this carbon. This is a nucleophile. This is a nucleophilic substitution reaction actually. So this nucleophile will be attacking the carbon and this bromine will leave from here. Now the thing is that this OH means if it is colliding with bromomethane, it must collide from the back side. Okay. अब देखो here this will be clear when you will study organic, but I'll try to make it clear. OH can attack from the front. Front side means where bromine is present, or OH can attack from the back side where this bromine is not present. So if it is attacking from the front side, now what happens? This is improper orientation, so no product will be formed. So attack जो होता है from back side होता है, so we get this transition state or intermediate, so that यहाँ पर simultaneously bond बनना शुरू होगा with carbon, and simultaneously carbon bromine bond will start to break. Okay, so after that this bromine will leave and this bond will form and OH will get attached, you will get methanol. So that's what we are saying ki the proper orientation is also important. If the molecules are colliding, like if OH is like अगर हम collision की बात कर रहे हैं, attack की बात अभी नहीं करते हैं, OH must collide from the back hand side. If it is colliding from the front hand side as same as bromine, so nothing would happen. OH must collide from the back hand side. Okay, try to understand. So to account for effective collisions, another factor P is introduced, which is the probability or steric factors. Okay, so it is actually taking into account that the molecules must be properly oriented. Okay, so collision theory में आपको इतना ही याद रखना है students, that activation energy and proper orientation of the molecules, they together determine the criteria for effective collision and rate of reaction. So अभी तक हम activation energy पढ़ रहे थे कि हाँ molecules must collide with a sufficient energy, they must like cross that energy barrier. Okay, they must cross that activation energy barrier and then they will convert to product. But that's not the case. We have now understood that activation energy plus proper orientation of molecules must be there. If there is no proper collision, if there is no proper orientation, product will not be formed. Okay. So that was collision theory, although this is not truly correct ki they are considering hard spheres, but these molecules have different orientation. We are ignoring their structures. Okay. So that we'll be learning in other theories in other chapters. But as of now, from the rate of reaction point of view, you have to remember this. That's why we are discussing it here. Ki proper collision as well as proper orientation as well as activation energy determine the rate of reaction. Okay. So that's it with this chapter, students. We have discussed all the topics for this particular chapter, and mainly the major topics these we have discussed in the last class, but here also some important things are there, like Arrhenius equation, and then that formula I gave you, effect of catalyst, and this collision theory. So isme se bhi you will be getting a lot of questions. So I already told you that it's an easy chapter but a scoring chapter. Okay, so don't skip it. Try to understand it thoroughly, and again I am telling you, if you are having any doubts, please do comment below and let me know ki ma'am I am not able to understand this topic. So what we will do is that we will make a separate video for that particular topic only, ki usko hum fir detail mein samjhenge, so that you can understand that. All right. So this is something very important, and I want you people to comment on the yesterday's video also, where I have asked you 2 questions. Today there are no questions, but try to tell me that whether you have understood all the complete chapter, or is there anything you are not able to understand. So 2 chapters are coming for BPT 8. Okay, that is redox reactions and chemical kinetics. So if you are having any issues, do let us know through the comment section. Okay, and all the very best for your paper. Score well. And thank you so much, students.